Hi, Viper Chemistry students. Hey, here's a problem I want to work on the board for you guys. And it is off of your student notes unit 7, Mass student notes. And it's a problem number 1, I believe. So I've kind of got the periodic table over here, or at least part of it. But anyway, I just wanted to emphasize that you might need to use the periodic table, or will definitely need to use the periodic table on these. Okay, so let's take a look at this problem, and it involves a balanced equation that's already given for you: potassium chloride, bromine, and produces a product of potassium bromide and chlorine gas. Now, in the problem, it gives you how much chlorine gas you start with, 162.5 grams. It's asking you to solve for how much of the potassium chloride would it be necessary to produce this much product of chlorine here. Now, to do these problems, what you have to do is you need to pick out the two items that are being worked with here. And so in this case, it's the chlorine, the molar. We want to find the molar mass of the chlorine because that's how many we have, the amount of the chlorine gas going in. So we need to know what the molar mass of chlorine is. So what you have to do is when you go to the periodic table, by the way, chlorine is right here, group 17, and it says it's 35.45. Now, what we're going to have to do is set this up times 2. So what I like to do on that is I just say, okay, 2 times 35.45 grams. And then when you do the calculation of that, it's 70.90 grams. Okay. Now, potassium chloride involves 2 elements, so potassium and chlorine. So when you look up potassium on the periodic table, it has a value. The atomic mass of that is turns out to be 39.09. So I always start with the first one, the cation. So 39.09 plus whatever chlorine is, and we've already said chlorine was 35.45, which again is its atomic mass found on the periodic table. Add those two together, and that gives us 74.54 grams. Okay, so now what we're going to do is set up our dimensional analysis problem so that we can end up solving for what's being asked. How many grams of potassium chloride did it take? So we start with what's given, 162.5 grams of chlorine gas. That's where you start, okay? So that's a given. And now we want to kind of break this down to its mole value. So like we set up a ratio of in 1 mole of that, we have a molar mass of 70.90 grams. So that's our first dimension of the dimensional analysis that we set up. Now what we want to look at is the mole ratio of the potassium chloride compared to the chlorine gas. So this, by the way, was chlorine gas. So now we want to set up our mole ratio. It turns out that there's only 1 mole of chlorine gas. I'm setting it down here, placing it down here so that we can cancel it. Now, what we're really looking for is potassium chloride here. So notice that there's 2 moles of potassium chloride. So our molar ratio is 2 moles of potassium chloride for every 1 mole of chlorine. Now, what we do next is we set up our molar mass dimension for potassium chloride, which in 1 mole of potassium chloride, there is what we said, there is 74.54 grams of potassium chloride. Now, at this point, we are ready to solve for the total mass. So turns out when you do a problem like this, you're really just considering all of these on the top side of the ratios are numerators, and these are the denominators. So you find the product of the numerators, then find the product of the denominators, and then do the division. When we do that, 162.5 times 1 times 2 times 74.54, and then divide that by 70.9 times 1 times 1, the value turns out to be 341.7 grams of potassium chloride.